All right, so this talk is more of how to achieve high availability and automatic failover in PostgreSQL, totally using open source solutions. Again, I know like a few of you have already attended my previous talk, sorry. And so have you deployed Postgres today in any of your, I mean, in your environment today? Like how many of you have deployed Postgres and already using Postgres today? Okay, great. And at the same time, like, are you using any of the commercial high availability tools, or you're using open source tools? Maybe open source? RDS. Okay, you're an RDS. All right, that's great. All right. Okay. So we are going to only talk about all the open source solutions that are available for us, and we are not going to discuss about any of the commercial tools, right? So what is high availability, right? So usually, whenever we talk about high availability, like we deploy our application data on the database, and we always think of maintaining another database server in another remote data center for high availability. But at the same time, the complexity comes when we have to do the failover. So what happens in a failover is, I mean, it's pretty easy to get the standby started, right, as a master, and it can now accept the writes. But the time that it takes to perform this failover, and also the time or the complexity that's involved in making changes in the application code to point to the new master, that is something that could be eliminated, so that you really do not need an administrator to really manually do something for failover, right? So that is something that we'll be discussing today. So at the same time, when we deploy that, we should avoid data loss and ensure that this process is totally seamless for the application as most as we can, right? And if a failover or a failure is detected, an action should be performed automatically. I mean, it's not like an alert should be given to a database administrator and the administrator would then perform the failover, right? I mean, gone are those days already. And at the same time, when we implement a high availability solution, we should also avoid single point of failures. So if there is a remote agent that's monitoring which database server is down, right? Again, what if that agent itself is down, right? So it's like we again need to have monitoring on top of monitoring. So that should be avoided. And at the same time, we should also be decreasing the unscheduled downtime. If we really want to do a manual failover, it should be pretty easy for us, right? And everything should be seamless. At the same time, we should also be able to perform a faster point-in-time recovery if needed, right? Let's say I've dropped a table, and if in case, I should be able to go ahead and get that table back, right? Most of the time, what we do is we'll do a point-in-time recovery, right? We need to go ahead and restore that backup onto another database server and take the backup of that table and restore it. That could involve a lot of time. However, we could even perform faster point-in-time recovery. So let's go ahead and see all that in action. So quickly, as most of you are not using Postgres already, I'll quickly talk about replication available in Postgres. Just like Oracle, where you have Oracle data guard kind of a thing, or even in MySQL, you have group replication as well as the native MySQL replication. Similarly, even in Postgres, by default, with the open source Postgres, you have streaming replication as well as logical replication. So streaming replication is something that you should be always deploying if you need to deploy a high availability solution in Postgres. If you would like to build some other replication and want to set up high availability on it, then that doesn't work much, right? Because that involves a lot of complexity. Streaming replication is pretty stable, and it is the wall segments, the write-ahead logs, or the transaction logs that are shipped from master to a standby. And those transaction logs are applied to the standby. So it's a binary replication. You could even consider a storage replication, right, which is byte by byte. And the standbys are also read-only, and you cannot perform writes on the standby. You can always perform reads on the standby. and you can set up synchronous and asynchronous replications. So if you would want to go ahead and set up a failover, an automatic failover, always try to prefer synchronous replication, unless your application could do something around the damage that's caused with the automatic failover with asynchronous replication, right? So because if it's asynchronous replication and a failover, an automatic failover happened, there's a chance that you lose some data. And if your application is smart enough to handle that, then that doesn't matter. But if your application is not smart enough and you want to put that on the database, go for synchronous replication so that the commit or a success message is only sent to the client when the change has been applied on the standby already. And at the same time, I was talking about faster point-in-time recovery. How do you achieve that? When you configure streaming replication, you could also add another replica that is delayed by a day or an hour or 2 hours or even 2-3 days, right? So that way, let's say somebody dropped a table now. You could actually go back to that replica that's already there, and you can replicate that table from the replica, right? Or you can fast forward that until an hour ago by just applying those transaction logs until that 1 hour. So in order to see how to do that, right, I cannot talk about that because that's huge. You could just search faster point-in-time recovery Postgres, and you would see one of my blog posts, okay? And that should help you. So quickly about logical replication. So logical replication allows you to replicate just table by table, the way you could do it in MySQL, and you could, but the DDL changes cannot be replicated, so you need to handle that separately. So that's why make sure that you kind of avoid logical replication if you are looking for high availability. And some of the features and extensions that you could have for high availability, right? Synchronous, and you could also go ahead and simply configure a trigger file or do a promote in order to go ahead and perform a failover. Like Oracle, like you don't have to perform, I mean, I know if you're using DGMGRL, like you could say failover to, right? It could be a single command, but there are some parameter changes, etc., that are needed, but you don't have that. And at the same time, if you would like to let the diverged master catch up, right? You could just simply use PG rewind. That could just put the old master back into replication and let it follow the new master. And that can be automated using some of the tools that we are going to talk about. And on the standby, please remember about these parameters. I mean, the slides will be available. So let's say you are running some kind of reporting jobs on your standby server, and if any changes have happened on the master, right, let's say a vacuum is running or etc., it can delete those tuples that are still being accessed by the reporting jobs on the standby. So you could avoid that by putting hot standby feedback as on, and the maximum delay through streaming that the standby can allow, so that your queries doesn't get terminated. And so you could go ahead, and I was talking about the delayed standby, delayed replication. So it's just a single parameter that you could put on the standby server or the slave, which is recovery min apply delay. So recovery min apply delay can be set to 1D, which means 1 day, or 1H, which means 1 hour. So whatever time you set to that recovery min apply delay on the standby, that amount of time, I mean the standby is delayed in replication by that amount of time. So a simple manual failover, right? You could just issue pgctl -d data directory of the standby promote. That's a simple command that you could run. And you know, most of the times when I ran it, the read connections that are already connected to the standby are not even terminated. The application did not even face any kind of a downtime for reads, at least, right? So it's pretty simple. So when you say PG is in recovery, and if it says false, it means it's no more a standby. It's not in recovery anymore, right? That's a simple function, which looks sometimes weird, but that you could just run to understand if the server is a master or a standby. You could also do another approach, like let's say you're using some kind of your own custom mechanism in order to perform a failover, and you would want a different way of performing the failover, right? You could configure or add this parameter called trigger_file and mention a location. So what happens is, if your application remotely does a touch/temp/failover, that means that file is created, right? And now the standby notices that that file is created, and it understands that it needs to failover itself, right? So it's pretty simple. You just need to go ahead and put this parameter in recovery.conf file of the standby. And when you do that, and if I touch, you see immediately the failover has happened. So these are the two ways to perform failover in Postgres manually, right? And now we are going to, this is what will be done by the automatic failover tools that we are going to talk about. So let's quickly discuss about the tools that are currently available, or the open source projects that are available, which are much more stable than the commercial high availability tools available today. Petroni, I would definitely say that it's the number one, and it's the one that's available with some of the Kubernetes operators as well, right? So you could just go ahead and use Petroni almost everywhere. PG Auto Failover is something that's being contributed by Microsoft and Citus Data, right? So that is still a version 1. However, you still have to monitor the monitoring for PG Auto Failover today, because there is just a one heartbeat checker that, or an agent I could say, that monitors both the master and standby. And if it does not identify that a master is, if it identifies that a master is not sending a vote to it, it immediately detects, checks for the standby and promotes it. But it's just one agent. There is no monitoring on top of this agent. Stolon, Rep Manager, Postgres Auto Failover, PG Lookout, PG Pull. We are going to quickly see about all these, but we also see some demo, right? Okay. Petroni, very quickly, right? So Petroni is a fork of Governor project, and so it talks to a distributed consensus key value store. We are going to quickly see a slide on how that works. We are talking about it could be an etcd or a zookeeper or console. So why is that distributed key value store needed? So Petroni relies on these key value store in order to identify who could be the correct leader or the master, right? So most of the times the biggest problem is, let's say we have a n number of nodes in Postgres, consider 3 for Petroni. Who should become the master, right? So you cannot go ahead and manually connect and check and make it a manual failover, right? So there should be an automatic mechanism so that the problem of monitoring the agent is also eliminated, right? So in order to avoid that, we rely on such distributed key value stores. We are going to see a quick introduction to how etcd works, right? And at the same time, Petroni does continuous monitoring, automatic failover, and even if in case a node goes down, Petroni could go ahead and add that node back to the cluster by rebuilding that as a replica if needed, right? And it has got REST APIs so that your application doesn't have to change any of the configuration strings, right? So your application just connects to a proxy that identifies what is a master or what is a standby using the REST APIs provided by Petroni. And totally transparent, right? If somebody kind of promotes and says they have an option with which they can perform a transparent application failover, so see if in case the design works this way, right? There is a distributed key value store, and so see how the consensus is happening, see if there is a need of monitoring the agent on top of it, right? So be smart on that. And also supports both manual and automatic failover. We are going to see a quick demo of how. So if you could see here, Petroni is set up on all the 3 nodes here in a 3-node master slave cluster, and we have etcd running. So let's quickly see how the etcd or the Raft algorithm works. So Raft algorithm is one of the industry standards and world's best algorithm for distributed consensus. And so quickly, let's see the demo. So we'll start with an example. So let's consider a single node system, right? If we have just a master, right, it may be pretty easy to say like a single value can be sent from a client, and you could tell if that node is available or not, right? That could work because it's just a single server, right? So we can have a client like Percona or any other manual client that could identify whether the value is sent and updated. If it returns that value, yes, okay, so we are in consensus. But what if we have multiple nodes, right? So if we have multiple nodes, I'm going to sit for a few minutes. And if we have multiple nodes, how do we come to consensus? So the client sends. So let's see a simple demo of how the Raft protocol works. So a node can be in one of the three states, right? It can be the follower state, a candidate state, or a leader state. So the first state by default that each node gets into is a follower state, and if it wants to become a leader, it participates in election and says, I would like to become a leader, and that's when it's in a candidate state. And then a leader is elected based on the votes between the nodes, right? So that's a leader state. So one can only be a leader at a time, right? So our nodes have started in the follower state, and if followers don't hear from a leader, they then become a candidate, and then each candidate requests votes from other candidates, and nodes will reply back, right? And the candidate becomes the leader if it gets votes from majority of nodes in the cluster, and that's a leader election. And now all changes go through the leader, and when client sends a message and says, okay, if it receives that feedback from more than one node or majority of the follower nodes, it's confirmed by the client that that's a leader. So we'll see a little more in depth on what happens next, right? So the entry is now committed on the leader, and the node state is 5, which is sent by the client, right? So most of the followers have sent it back, and it has got into consensus now. So it's a log replication that's happening internally, which we don't have to be aware of. So let's quickly look into the term and the timeout settings that are there, because each node can go ahead and request for votes, and each node gets a message back, right? So what happens is there are two timeout settings. Election timeout, it is the amount of time a failover waits until becoming a candidate, and that's randomized between 150 milliseconds to 300 milliseconds. The chance of it being the same on two nodes is rarely rest, but even that situation is handled. We'll see how that works, right? So now the timeout is pretty less on node A, right? So the follower becomes a candidate and starts the election term. So it first votes for itself, right? And then it sends out request vote messages to other nodes, and if these receiving nodes haven't voted for themselves yet, that is when they send a vote back, right? And now the election timeout is reset again. So that's because the candidate has got the majority of votes, it becomes the leader, and it just begins sending out append entries to its followers, and then there is a heartbeat timeout, and the followers respond back. It's all the confirmation that's happening internally, and the election term will continue until it stops receiving heartbeats and becomes a candidate. So now this is the leader, right? So Petroni relies on this HCD or the Raft algorithm to go ahead and run its next or further set of commands, right, in order to see what should I do next. Like, should I promote another standby, another leader, or should I go ahead and rebuild another old leader as a standby, right? So Petroni relies on this consensus. And what we'll do is we'll get back to the automatic failover scenario where we'll stop the leader and watch a re-election happening, right? So now node B and node C are participating in elections, right? So looks like node B would want to become the first candidate, and it is now a leader of the next term. So requiring a majority of votes guarantees that only one leader can be elected per term. Now we are going back to the situation where, what if both the nodes becomes candidate at the same time and they have got the same timeout settings, because that's when a split vote can occur, right? So I mean, we got 4 nodes instead of odd number of votes. And now, node A and node C have started voting each other at the same time, and each reaches a single follower node before the other, and each candidate now has got 2 votes and can receive no more than these 2. So the nodes will now wait for a new election and try again, right? So this is something that's happening internally, and now node D received a majority of votes in the term phi, so it becomes a leader. So this is one of the, I mean, I don't think we have to go through the next things, the log replication, just in the interest of time, but this is what is happening internally in Petroni, and that is why, like, I mean, not just Petroni, there are some other high availability tools like Stolon that are still kind of in the development stage, I would say. They are deployed in some of the environments. However, Petroni is totally stable today, right? So something that I can strongly go ahead and believe that I can put in a very, very critical production environment, because that's already deployed in such instances today. And I really don't need to touch those production environments for failover or high availability. I really don't have to monitor it. I'm so happy that I can just put it onto Petroni and etcd. So using the APIs provided, the REST APIs, you could go ahead and put the configuration settings in HA proxy in such a way that it can identify what's a master or a standby automatically through the configuration file. So how many of you were there in yesterday's session where I was showing you how automatic failover works through Petroni? Okay, right. All right. Okay. So I'll again show you very quickly, as majority of you're not there in yesterday's session. What I'm quickly doing here is I'm going to go ahead and connect to the Petroni cluster that I've set up for this demo, right? And here I've got PG0 as my leader, right? And I would go ahead and also connect to my 2 other nodes, and one of the application servers rather. So I've got a Python script here that's trying to connect to the Petroni cluster and doing an insert, right? So now it has connected to a master that is 172.30.3.133, which is the server, right? And now what I would want to do is I would want to perform a failover, let's say Percona is doing it internally when one of the nodes is not available. So even it's so easy for manual failover that you could just say failover or switch over and just choose the next candidate yourself. In order to choose the candidate automatically, it relies on etcd, but now we are doing it manually, right? So it asks for confirmation in demoting the current master, and we said yes, go ahead and perform the failover. And now we are quickly going to go ahead and list and check what are the nodes that are currently running. So now PG1 is the leader, as you could see, and this has already started following PG1. PG0 has already started following PG1, and my script is able to connect to the new master automatically. Earlier it was 3.133, and now it's 3.216. How? Right? So I'll quickly show you how that works internally. So I've got the HA proxy that I was showing on the top layer in the in the Percona architecture diagram, right? So what it's doing internally is it's trying to connect, to port 5000. My script is connecting to port 5000, right? And my HA proxy configuration is trying to do an HTTP check and see which server among these three receives the status as master. So it's all using Percona API, right? So now Percona returns master status for PG1. And likewise, if I would want to send my read transactions or read queries only to the standbys, I could just go ahead and search for replica, and now it returns PG0 and PG2 as replica, and in the round robin fashion or any algorithm that I choose, it pushes the further queries to replicas only. So for my application, it's seamless. I don't have to manually go and edit any of the like I do in Oracle, like changing all the TNS entries or maybe etc. stuff, or using scan. All that's pretty simple. All right, so you could also implement PG bouncer on top of it if you would like to go ahead and put a connection pooler, right? And this is what I wanted to show is like you could use monitoring, backup server, everything, and this looks like a totally complete enterprise grade setup, totally using open source. Now we'll talk about how about HA on Kubernetes, right? How many of you are already using Kubernetes in your infrastructure today? Okay, all right, quite a few. So I would, if you would like to go ahead and set up such an HA cluster using Percona on using Kubernetes, right? You could use Zalando's Postgres operator that ships today with Percona, and the architecture diagram looks like that. And there is another Postgres operator which is shipped by Crunchy, and however, that does help you with some of the monitoring and master, standby, streaming replication setup, and backups like PG backrest, very good backup solutions. However, Percona is something that you could get with Postgres operator shipped by Zalando that looks like this. This is the custom resource definition of that operator, like how it set up the services, stateful sets, and the pods, right? So you could use persistent volumes, and it's pretty simple to go ahead and use Zalando Postgres operator rather today, because there is another method with which you could set up HA on Kubernetes using Stolon, right? However, that ships containers that could help you use master, standby containers, and manage it a little manually, but I would prefer the way of using Zalando Postgres operator today that ships with Postgres by default, Percona by default. And the second HA solution that I'm going to talk about is Rep Manager, that's currently maintained by Second Quadrant. And Rep Manager uses a Rep Manager daemon that's installed on all the servers, like master, standby, and these daemons talk to each other. And there is also another, there is also other arbiter kind of a thing that you need to set up that monitors the daemons and lets you perform the promote. At the same time, rep manager can be really helpful when you would want to perform a series of actions upon a failover, right? Let's say upon a failover, you would want to manually, because not every environment can have Percona kind of a setup, right? Because you may have to do a lot of application changes internally whenever it changes from one data center to another data center, right? And you may want to switch your application to another data center to reduce the latency, or there are some other series of steps that you might want to perform. So you could pass a Python script or a manual script to the promote command of rep manager as an action that it needs to perform upon an automatic failover, right? In such situations, you could use rep manager. Rep manager 4 release recently happened, and it also helps you easily spin up a streaming replica with simple commands, promote a failover with simple commands. So you could just test that. But if I'm configuring a high availability solution in my environment, that is something that I can rely on a simple master standby replication, I would still go with Percona. Stolen, it again works on the same distributed consensus, the way etcd, the way Percona relies on, right? It again relies on a etcd or console or Kubernetes API server, and it has got a keeper that maintains a cluster view, and Sentinel that monitors the keepers and performs the action like, should I perform a failover or not, right? And there is a proxy that can decide what's a master, that can redirect the connections automatically to a master. So Stolen is also another open source solution that's developed and it's maintained well. However, still Percona has got its predominance to it. So there's just a simple architecture diagram that you look like. So there is a proxy that lets you automatically connect to the master for writes, right? And the keeper monitors the status, and Sentinel monitors the keepers and see if it needs to perform a failover, and it does depend on etcd kind of a distributed consensus. And finally, pgpool2 is something that you could use in your environment that supports not just connection pooling, replication, load balancing. It also supports automatic failover, but the only downside to pgpool is that it parses each query that's shipped to the database server. So pgpool is outside of the database server. It can be installed on the database server as well. It's another layer. So your application connects to pgpool, and pgpool redirects the connection automatically to a master or a standby. Let's say you would want it to manage redirection of only writes to the master and reads to slave or master and slave in a load balancing fashion. And you don't want to know that logic yourself. You don't want to put such a logic on your application. So you could actually use pgpool for it. Pgpool can parse every SQL statement, and it can determine if that's a read or a write, right? And then it can ship a write only to a master. So that logic can be there, used with pgpool if your application really strictly cannot determine what's a read or a write. However, the downside to it is that this parsing is an extra layer, and we have actually identified that this parsing has reduced the performance a lot on critical transaction systems that takes like, which is like a OLTP that takes like 1,000 transactions or 500 transactions per second. In such a setup, pgpool may not be good enough, but it still is implemented in production and really running well since many number of years already. So a few points to note. Not every high availability tool that we discussed about might work for your environment, right? You could use, I could say a very good number of words about Percona today, or Stolen, or maybe pgpool, but that could be useless for most of the production environments. So sometimes we might need to build our own automatic failover using custom scripts or maybe some of the logics that we use internally. That is why when you would want to move to Postgres, right, you need to kind of think about the high availability that you would want to set up on your Postgres and help your applications be developed in a way that it can cope up with the high availability solution that you have implemented on Postgres as well. Because whenever you're implementing something on database server, it is not something that you would want to implement based on how my application is working today. Because you would also want to let your application handle what is a read and what is a write. If you want to do that on the database, like using PG pool, that's an extra layer that could cause performance issues. So always have what kind of high availability solution you would want to implement in first before any such migrations. And at the same time, be prepared for a data loss if you're not using synchronous replication. And if you would want to pause your failovers, manage it with a certain parameters that can stop failover upon a certain condition, right? Let's say there is a lag of replication. In Percona, you could say max lag on replication equal to 120 milliseconds. So if there is a replication lag of more than 100 milliseconds, it would not perform the failover. It just waits for you to do it manually, right? So also make sure that you perform your updates, upgrades, and look for the updates on the high availability tools that you have implemented, because if there is a bug that has been identified, there may be a patch to it, so you always need to monitor it. Just implementing it, I've seen people implementing PG pool and they have not upgraded it for 3 or 4 years, right? So that's not something that we should be doing in our environments. So yeah, I think that's everything to discuss today. And if you have any questions, I would want to take them. Yeah, so this HCD will be running in each node, right? And there is a timeout that's set, yes. So if in case one node that is distributed across some other, I mean, it's partitioned by network, and it's in a different data center, and it took time, right? So whichever node has got the vote or the more number of votes from the followers, right, or more number of votes within the cluster, it automatically becomes the leader within the timeout, right? So it would not again wait for another remote node, because this node is available or not depends on how many nodes are able to reach it, right? So if that node is not reachable due to this network partition, right, I mean, that would not be in the election anymore. Yeah, but it did work well and works well with the even number of votes as well. It doesn't need, I mean, we have seen how 4 nodes were there and 2 nodes voting between each other at the same time, right? So that election is no more applicable. It again looks for the next turn. Yeah, usually odd number of nodes is something that we set up. That is something that we have been used to because of the way we have been monitoring database server using agents so far, right? So, but I think today it's okay, but yes, odd number of nodes is usually preferred.
Is this only for Postgres, or it will work the same for Mongo? Because Mongo needs extra nodes to vote.
For Mongo, I'm not sure, but for MySQL, yes, there is orchestrator that actually runs the same way. For Mongo, I think there is an arbiter that actually monitors the master and standby, and I mean the shard master and standby, and within the shards it promotes based on that. And I also know that there can be an arbiter on top of an arbiter that could, or multiple arbiters that could actually decide who is available in a situation where you would want to avoid the failures related to agent being down, right? Arbiter being down.
The arbiter would need extra nodes.
Yes, yes, that's right. So yeah, so even Mongo takes care of it automatically by default. Yeah.
But it requires at least 2 nodes plus arbiter.
At least 2 nodes plus arbiter. Yes, that's right. Yeah, yeah.
I think this is more elegant solution.
Oh yes, yes.
It would be nice to have it in
Yeah, yeah. I'm really not sure how it works in Mongo because it's been a couple of years that have touched it, but I'm aware of the architecture that I've seen 2 years ago. So maybe we need to talk to some other MongoDB experts here. Yeah? All right. So I could take any other questions if you have, not just on high availability. Any other questions that you have in Postgres in general, you could definitely ask, for sure. Yeah. Yeah. So there is a way to pause the failover upon such an event using some parameters, like Percona offers 90 odd parameters which you could set up, and one among them is max lag on replication, right? So you could say if replication lag is more than certain time, you could avoid the failover. But let's say you did not put that, and for you availability is a very big concern, and you do not want to go with synchronous replication and just want to make it asynchronous, right? In such a situation, you need to, again, instead of letting Percona rebuild the server, you need to enable the option to which you would say Percona should not be rebuilding the old master as a standby again. And you need to manually get that data that's not there in the standby, and that should be, again, done using SQLs that you should be performing manually. But whenever it's asynchronous, we need to be perfectly clear that it involves some data loss, right? And we need to see if our application can handle that. If it cannot, then we should let Percona stop a certain activities, either the failover or rebuilding the old master. Mm-hmm. Yeah, yeah. I mean, you could use wall to JSON kind of extensions using which you could see what's in a wall, but that's all a huge manual approach. Usually, I don't think any of the database can help with that. Maybe MySQL could do with the way it captures the statements in the binary logs, right? That could be possible. But maybe you need to enable detailed logging so that you could see those SQLs in the log files of Postgres, right? So, but apart from that, it's not so easy, I would say. It involves a lot of manual effort. Any such divergence requires manual effort. Yeah? All right. So we have good time for lunch then, I think.
Thank you.
Yeah? All right. Yeah, thank you.